Before we tackle the second iteration of the RCNN models, I wanted to mention another architecture called SPPNet. SPP stands for Spatial Pyramid Pooling. The main contribution of SPPNet to the object detection task is the ability to remove the resizing step of the RCNN architecture, and by doing so, reducing the cost of computation. So let's take a step back together and remember why convolutional neural network need a constant size input. Well, the dimension of the output volume of a convolutional neural network depends on its input shape. However, at the end of a convolutional neural network, we have a stack of fully connected layers, as we have seen previously. Such layers take a fixed size input. Therefore, we need a fixed size input for the convolutional layer. Here comes the SPP layer to the rescue. This layer takes a variable size input and outputs a fixed size feature vector. So how does this work? Well, let's consider a variable size input. The SPP layer will split such an image using different fixed splits. In this example, we are using two splits, a 2x2 and a 2x3. We can then use a max pooling layer to calculate the maximum of each one of the splits. So we went from a variable size image to a 2x2 and a 2x3 fixed size outputs. We can use different filter sizes, such as 3x3 or 1x1. By the way, given that we are using two splits here, the spatial pooling layer will be described as a two-level SPP layer. So let's summarize what the SPP layer is doing. It splits a variable size input and pulls the splits to create a fixed size vector. Let's see how the SPP layer fits in our object detection algorithm. SPPNet differs from RCNN in the following ways. It starts similarly to the RCNN model by calculating regions using selective search. However, instead of resizing and feeding each one of the regions to the ConvNet, SPPNet uses the full image to feed into the ConvNet. The output of the last convolutional layer is then cropped using each region obtained by the selective search. These regions are then fed into a SPP layer and therefore given a fixed size output vector that can be used by the classifier. We need to keep in mind that the SPP layer is applied to each channel of the ConvNet output. So let's use our previous example and assume that we use a 2x2 and a 2x3 split in our SPP layer. And let's assume that the output of the ConvNet has 256 channels. For each region of the selective search, we are creating an output of dimension 256 by 10. How is this an improvement over the RCNN approach? Well, first, we are reusing the feature maps calculation instead of feeding each region into the ConvNet directly. Moreover, we do not need to resize each region anymore. While maintaining similar performances, the SPPNet improved the speed of RCNN by a factor up to 100. The author of the RCNN paper used this novel approach for the next iteration of region-based ConvNet, FastRCNN.